In this video, we're going to take a look at rationalizing the denominator when we have to use something called the conjugate. And before I get into too much about the conjugate, let's just kind of review what we want to accomplish. And so when we're dividing radicals, we don't want to leave a radical in the bottom. So our goal is to get rid of these radicals in the bottom without changing the value of the initial fraction. Now to do this, we have two binomials. We can't just use the same thing that we did before, which is just simply multiply through by one radical and magically things will disappear. So we need a different strategy. Now you'll notice that this is a binomial underneath, meaning it has two terms. And if we were to multiply a binomial by a monomial, we'd get another binomial. We don't want that. What we really want is we really want a single number under here if possible. But more importantly, we want the radicals to go away. Well, if I multiply by a radical of 5, then I'd get radical 15 minus 5. And that would do it, except that we still have one radical underneath. Likewise, if I were to multiply by a radical of 3, then we'd have the radical of 3 times radical of 3 is radical of 9, and so we have the square root of 9, which is 3, and then we would combine underneath to get the radical of 15 again. Well, that doesn't really work either. And so it looks like we might have to do some kind of a combination of root 3 and root 5. But we want to do it in such a way that we don't create any other terms involving radicals. So over here, let's just play a little bit and see what happens. Well, if we use root 3 minus root 5, that's what we start with. Now, we're just guessing here. So I'm just going to go ahead and say, well, if I have to multiply by root 3 and root 5 again, let's just go ahead and see what happens. Well, when I go ahead and distribute, I get the square root of 9 minus the square root of 15. And then here, I get the square root of, minus square root of 15 again, and I get plus square root of 25. When I simplify this down, that gives me 3 minus 2 roots of 15 plus 5, or 8 minus 2 roots of 15. Well, I still have a square root. Well, that's not good, because I want to rationalize the denominator. That's the point. And so that particular method is not going to work. But you can see how I eliminated one of them. I might be on the right track here. So let's just go ahead and eliminate this here. And let's try it again. And so I've got square root of 3 minus root of 5. And I have to multiply it by a binomial, and I have to have 3's and 5's involved, root 3 and root 5. I tried to run the same sign as before, but now I run the opposite sign. Let's just see what happens. And so again, I go ahead and I distribute. That gives me root 3, and root 3 gives me root 9. And root 3 and root 5 give me plus root 15. Over on the next set, when I distribute, I get negative times a positive is a negative, and root 5 and root 3 give me root 15. And then I get negative root 5 and a positive give me a negative. Root 5 and root 5 give me root of 25. Well, when I clean this up a little bit, I get 3 plus the root of 15 minus the root of 15 minus 5. That gives me negative 2, except that if you look here, any number subtracted from itself eliminates, becomes 0. That gives me negative 2. That right there has no radical sign on it. Then that's accomplished what I need to accomplish. It has gotten rid of the radicals. And so we're going to use this technique then. Now, these two things have a name for them. They are called conjugates. I'm going to erase this. And then I'm I'm going to write it over here. So if I have two things like a plus b and a minus b, these things are called conjugates. The conjugate just means you have a binomial and you simply replace the sign with the opposite sign. Okay? If you do that and you multiply conjugates, you get the difference of squares. Well, that's that difference of squares that we want to use here, because that means if we have difference of squares, the individual things are squared, then we could go ahead and cancel out the root. You cannot simply square the bottom. The effect of squaring the bottom is the first attempt that we made over here, where we had root 3 minus root 5 times root 3 minus root 5. It didn't work. You can't do it that way. If you're still struggling with that, you cannot distribute exponents over over addition or subtraction. It doesn't work that way. So we're going to use this idea here, the idea of the conjugate, and we're going to multiply the top and the bottom by conjugates. And so everything is done on basis of the denominator, because that's what we want to rationalize. So the conjugate of that is going to be root 3 plus root 5. And we want to multiply top and bottom by the same, because the effect is then I multiply by 1 and don't change the value. Okay, so now we have to distribute this 3 to both terms on the top. That gives us 3 times root of 3 plus 3 times root of 5. On the bottom, we have the square root of 3 minus root of 5 times root of 3 plus root of 5. And you can go ahead and do this multiplication on the bottom over to the side, so that you have root 3 minus root 5, root 3 plus root 5. We get a little bit sloppy when we talk about square roots. We'll just say root. If we're talking about cube roots, we'll say cube root of. Okay, so now we go ahead and distribute, and that gives us the square root of 9 plus the square root of 15. And then on the second round, we have negative roots of 15 minus root of 25. That gives us 3 minus 5. These eliminate. And it gives us negative 2. So when we rewrite our second step here, we're going to have 3 roots of 3 plus 3 roots of 5 all over negative 2. At this point, I recommend that you either put the negative out in front or distribute it among the top. I hardly ever leave the negative on the bottom, even though it is technically correct. Reason being is it interrupts my slope idea. And so I've developed a very intimate relation with a particular way of viewing slope, and the negative on the bottom kind of screws that up. So I tend to just say, okay, it's the negative of 3 roots of 3 plus 3 roots of 5 over 2. Now you try to combine the top, but as you notice, we need a common indices, which we have, but we also need common radicands, which we don't have, and so we can't add those up top. It depends on your instructor, or depends on which problem or what the instructions are for that problem. You may leave it like this. They might want you to factor that 3 out, and so that it looks something like this. Root of 3 plus root of 5, and you factor the 3 out. I really don't see a difference in the two. You're still going to have to do that calculation. That's rationalizing the denominator when you have a binomial in the bottom.